Aim of every soldier is to achieve the aim of Ek Goli, Ek Dushman. This can be achieved while he is given training during peacetime. To give the soldier training, simulated battle conditions have to be created. For this, we have gallery ranges and field firing ranges. Since the training is given during peacetime, care has to be taken about the civilian property and life. So we have the danger area templates, and this is applied on ground so that no danger exists to life, limb or property. As members of board detailed for construction and siting of ranges. Thus, it becomes imperative that we know danger area templates for different ammunition and its application on ground. Aim. The aim of this CBT package is to acquaint you with the construction of danger area template and its application. This CBT package will be covered under the following parts. Part 1, Definitions and Principles of Template Design. Part 2, Method of construction of danger area template for small arms ammunition. Part 3, Method of construction of danger area template for exploding ammunition. And in Part 4, we shall see application of the danger area templates. Part 1, Definitions and Principles of Template Design. In this part, we shall cover some important definitions and principles of template design as seen on the screen. Let us see them one by one.
Danger area, that area of land or water together with the unconfined specified aerial volume above them within which danger to life, limb or property may be expected to occur arising from the initiation of specified ammunition, explosives or ordnance natures. Firing point or firing area, the position on the ground oblique map from which firing takes place. It may take the form of a point for firing individual weapon or a line for a number of weapons or area for one or more weapons firing from different positions. Arc of fire, that area within which firing is to be directed. It is measured from the firing point or the firing area. Ammunition danger area, the area beyond which specific initiated ammunition natures may not be expected to travel, ricochet or fragment. This area includes the arc of fire and ricochet area. Ricochet area, that area of ammunition danger area which is outside the arc of fire. It is therefore the area beyond which ricochets may not be expected to travel. Burst safety area. It is the area outside the ricochet area beyond which fragments of the explosive projectiles may not be expected to travel. Principles of template design. 1. Ricochet factors. 2. Danger from exploding ammunition. 3. Danger height. Ricochet factors. A ricochet is supposed to have occurred when a projectile strikes a surface and rebounds once or more. If a projectile strikes at an angle of less than 530 mils to the surface struck, it may ricochet up to 800 mils on either side or vertically. Maximum ricochet range or MRR, the range at which the projectile achieves an angle of descent of 530 mils is taken as its MRR. Weapon elevation at this range is the elevation beyond which ricochet will not occur. Maximum range of a weapon is more than its MRR achieved at an higher elevation. Lateral distance and the angle of ricochet travel depends upon the type of surface struck, that is, hard surface or ground surface. Lateral distance, hard surface 1/4 of MRR, ground surface 1/8 of MRR. Angle of ricochet, hard surface up to 800 mils, ground surface up to 530 mils. Ricochet behavior of 7.62 mm ammunition. The maximum range achieved is about 3,900 meters, theoretically at a weapon elevation of 45 degrees, but this is practically achieved at an elevation of approximately 22 degrees. Remaining velocity at 3,900 meters is 107 meters per second, implying that it is lethal throughout. Critical angles for ricochet: ground surface 7 to 8 degrees, softwood 10 degrees, hard surface 28 to 30 degrees. Maximum reduction in the velocity of a ricocheted bullet is to the order of 60%, and the ricochet angle is up to 3.5 times the angle of impact. Bullet becomes completely destabilized and deformed when post-ricochet deflection is 20 degrees and above. At shorter ranges, nature of surface struck exercises little effect on ranges of ricochet. The further a bullet travels before it strikes the ground, the less is its range on ricochet. MRR or 7.62 mm bullet is 2900 meters, which is also the range of free flight of the bullet corresponding to 530 mils. Danger from exploding ammunition. Ricochet factors. Danger from exploding ammunition. Reduce safety distance. Distance at which the chance of being hit by the most far-reaching fragment is reduced to an acceptable risk. Applied in training, trials, or demos when fewer than 100 persons are involved. Normal safety distance. Distance beyond which it is theoretically impossible for fragments and blast to travel. Applicable to demos or exercises where more than 100 people are present or civilian property is involved. Danger height. Danger height. These are dictated by either vertex height of the projectile or its maximum ricochet height, whichever is greater. These are related to mean sea level.
Part 2. Method of construction of danger area template for small arms ammunition. In this part, we shall cover the following: gallery ranges, method of construction for 7.62 mm ammunition, and DA template for 9 mm ammunition.
Gallery ranges. Purpose-built ranges with reduced danger area because of range design and construction. Maximum quadrant elevation should be 89 mils.
Method of construction of DA template for 7.62 mm ammunition. Method of construction of DA template for 7.62 mm ammunition consists of following steps. Step 1. Taking out human error angle. Step 2. Ricochet angle. Step 3. Determining ricochet boundaries. Step 4. Making completed templates. Step 5. Transferring to TALC. And step 6. Making template annotation. Let's see each step one by one.
Step 1. Human error angle. Draw a single center line. This is the line of fire. From the firing point A, measure a distance to scale of 2900 meters along the firing point B. 2900 meters is maximum ricochet range of 7.62 mm ammunition. At point B, draw a line of any length 1600 mils, that is 90 degrees to the line of fire. From point A and on each side of the firing line, draw lines AC and AD at an angle of 40 mils to AB 40 mils is the human error angle. Draw a line from point A at an angle of 530 mils from line AD. Similarly, a line at an angle of 530 mils from AC. 530 mils is the maximum ricochet angle. From points C and D, draw lines back at an angle of 800 mils to meet the line.
Step 3. Ricochet boundaries. Draw lines WX and YZ parallel to AD and at a scale distance of 400 meters, that is 1/8 of maximum ricochet range, and 800 meters, that is 1/4 of maximum ricochet range respectively from AD. Similarly, draw line PQ and RS parallel to AC. This gives us the ricochet boundaries. Step 4. Completed templates. Erase all construction lines to leave the 7 shape AR, SC, DZ, Y. Here, lines PQ and WX denote the ricochet danger area for a ground surface oblique soft targets. Lines RS and YZ denote area for a hard target oblique surface. Finally, check all angles and scale distance.
Transfer to talc. Place the talc on the top of the drawing sheet and secure it. Using a sharp object, draw lines on the talc. The lines drawn for human error angles need not be etched as they have no use once shape is determined. The center line, which is the line of fire, is lightly etched onto the talc. Remove the talc from the drawing sheet and cut along the outside lines to remove the template from the sheet. Use fine sandpaper to rub off any burrs along the edges of the talc and correct any oversized bias in the shape. Where DA template is prepared for ground and hard surface, the ricochet boundary for ground surface also be etched and kept marking on the talc. Finally, check the template against construction drawing again.
Step 6. Template annotation. Following information must be written on each template: caliber of ammunition applicable, nature of ammunition, that is ball, tracer, HE, smoke, IL, etc. Nature of targets, that is ground or hard. Scale of template, owner's name, firing point. This is to avoid usage in reserve, and Quadrant elevation applicable.
DA template for 9 mm ammunition. Method of construction of DA template for 9 mm ammunition is same as that of 7.62 mm ammunition. In case of 9 mm ammunition, maximum ricochet range is 1500 meters. For added safety, it is taken as 1600 meters. For soft surface, it is 1/8 of MRR, that is 200 meters. For hard surface, it is 1/4 of MRR, that is 400 meters.
Method. Part 1. Definitions and principles of template design. In this part, we shall cover some important definitions and principles of template design as seen on the screen. Let us see. Part 2. Method of construction of danger area template for small arms ammunition. Part 3. Method of construction of template for exploding ammunition. In this part, we shall cover the following: burst safety distance, DA template for number 36 hand grenade, DA template for number 36 HE rifle grenade, DA template for 51 mm mortar, and DA template for 84 mm RL.
Burst safety distance. Each type of exploding ammunition has a radius from the point of burst within which a danger exists from fragments, debris, or blast.
Method of construction. Draw a rectangle ABCD to scale with length 46 meters and width 30 meters, side AB being the firing bay. Draw arcs to scale for radius of 210 meters and 300 meters from points A, B, C and D as reduced and normal safety distance respectively. Join the arcs by straight lines along the common tangents to the arcs. Finally, give appropriate template annotations. Danger area template for number 36 HE rifle grenade. Method of construction. Draw rectangle ABCD to scale with length 150 meters and width 46 meters. Side AB with length of 46 meters being the firing bay or point. Draw arcs to scale for radius of 210 meters and 300 meters from points A, B, C and D. Join the arcs by straight lines along common tangents. Finally, give appropriate template annotations.
Method of construction. Select a firing point A and the line of fire AB, point B being at a distance of 502 meters to scale. Draw an arc to scale with radius of 502 meters. Draw lines AC and AD each at an angle of 267 mils, that is 15 degrees. The line of fire AB intersecting the arc at points C and D. 15 degree denotes the safety angle on either side of line of fire. Draw arcs to scale with radius 852 meters and 1002 meters concentric to the arc CBD from firing point A. Draw arcs to scale with radius 500 meters and 350 meters in the direction opposite to that of direction of fire from firing point A. Join the inner and outer arcs respectively with straight lines along common tangents. Draw an arc to scale at a distance of 185 meters from the firing point, cutting the lines AC, AB and AD. This denotes the distance within which targets should not be engaged with HE ammunition. Give appropriate template annotation.
Construction of danger area template for 84 mm RL. The relevant data and design of danger area template for HE, smoke and ill ammunition for 84 mm RL is given in pamphlet issued by FFV Sweden, which gives peacetime safety precautions. Part 4, Application of DA templates. In this part, we shall cover the following: arc of fire, range boundary considerations, and DA template fire and move exercise. The overall size of the exercise danger area is determined by applying the point of the template to the firing point located on the map and swinging the template as far to the left and right. The center line of the template indicates the maximum left and right of arc for that exercise. Range boundary considerations. Here we are depicting range boundary by red color. Danger areas for targets A and B fall outside the range boundary, whereas danger area for target C falls within the range boundary. Hence, it is safe to fire at target C. Targets A and B cannot be engaged because the ammunition danger area does not fall inside the range boundary.
Fire and move exercise. The range boundary is depicted by red line. To carry out fire and move exercise, the DA template is placed at the starting point within the range boundary. Here, a section is depicted by a soldier. When this section reaches edge of the DA template, the DA template is turned right so that it lies within the range boundary. The section also moves right so that they move within the DA template. On reaching the edge again, the DA template is again turned in the direction so that it lies within the range boundary. The section also moves in that direction. In this way, the DA template can be turned a number of times and the exercise carried out.